Is he still there?
Okay, let's continue, ladies and gentlemen. I've also started recording this meeting. I hope you will be able to finish the other method. We'll be able to finish discussing the other method before the end of the first 40 minutes. So kindly mute your mic. Those who are just joining in, please mute your mics. Okay, let's continue. So I earlier on mentioned that we are going to discuss only two iterative methods, that is the Jacobi's method and the Gauss-Seidel method. So now let's discuss the Gauss-Seidel method. Okay, so this method is similar to the Jacobi's iterative method. The only difference here is when we first find the first approximation of small x11, we need to use that to find the other three approximation or the other n-1 approximations, right? Okay, so instead of having this formula for finding xk, remember for the Jacobi's method, we said that we can express xik in this form, 1 over aii, then this summation of minus aij. So you can write it in general form as follows. Okay, so you will have that where j is not equal to I, then plus bi. You can write it in that form. Now, what we'll be doing is, when I want to move on to x2, for example, then I need to make use of x1, which I found from the previous approximation. Okay, from the previous approximation. For example, using example 3.15, we saw that x2k was given by 1 over 10, then x1k minus 1, then plus x3k minus 1 minus 3 x4k minus 1, then plus 25. Okay, that is from example. So let me do this. This is from example 3.1.5. Okay, we're able to write x2 in that way. But as we are finding the value of x2k, we'll have found the value of x1k. Okay, because we'll start with x1k. So we see that that value can be substituted in there. Instead of using xk minus 1, we can use xk. So if we do that, then we'll just substitute that value. Then x3k minus 1, since I haven't found x2, so I can't find x3. So this one will remain the way it is, x3k minus 1, right? And x4 will remain like that, x4k minus 1, and so on. So the only difference here is that I'm using previous approximations to find the next approximation and so on, right? So let's try to use the same example, example 3.15, but this time around we are going to use the Gauss-Seidel method. Okay, so maybe let me just write the general form of the Gauss-Seidel method. So if you'll be using the previous approximation, then each xi can be written in this way. So xik will be written as 1 over aii. Then if I want, I can start with bi, then minus this summation up to I minus 1, okay, j equal to 1 up to I minus 1 over aij xj k. Okay, so these are the values I'm getting from the previous approximation. Okay, so I'll say this is coming from the previous approximation. Okay, I'll get these and substitute them in there. And then those which I haven't found, then I'll write them the way they are. Okay, summation from j equal to I plus 1 over aij xj to power k minus 1. Right? That's what we are going to do. So in general, it can be written in that way. Of course, we know I is from 1 up to n. Again, here we need to make sure that aii is not equal to 0, because if it is equal to 0, then this part will be undefined, right? So we don't want that to happen. Okay, so let me get rid of this. Okay, good. So let's do example 3.1.5 again, but this time around we are going to use the Gauss-Seidel method. So I'll call this one example 3.1.6. Okay, so remember we have this system of equations. So let me write the same system of equations. 10x1 minus x2 plus 2x3 is equal to 6. Then minus x1 plus 11x2 minus x3 plus 3, x4 is equal to 25. Then 2x1 minus x2 plus 10x3 minus x4 is equal to negative 11. Uh-oh, power has gone for someone here. Sorry. You'll be able to watch the same video on the Moodle. You'll be able to download it from Moodle. And then the last equation is 3x2 minus x3 plus 8x4 is equal to 15, right? So again, I'll make x1 the subject of the formula from here. So x1k will now be equal to x2k. Okay, so if I want, I can even divide by 1 over 10 already here. So let me get rid of this part. Sorry. Okay, so I'll get 1 over 10, then x2k minus 1. Since I'm finding x1 here, then there's no way I can know the value of xk. So I need to use the xk minus 1, which is coming from the given initial approximation, right? And then the next value will be minus 2x3. Again, here I need to use the initial approximation k minus 1. Okay, and then plus 6 here, right? So after doing this, I need to substitute the values of x2 k minus 1 and x3 k minus 1, so that from here I can get x1, 1. It will have zeros in there. And then if I make x2 the subject of the formula, so x2k will now be equal to what? 1 over 11 there. Then I'm going to have minus, okay, so I'm going to have minus, okay, it will be positive now, x1k. So I'll just say x1k. I would have said x1 minus 1, but at this stage, I will have found the value of x1. So I can substitute the value of x1 in this equation. So I will just have xk here. Sorry. Let me write it like this. Okay. So I'm going to have xk in there, right? And then I'm going to have plus x3. I'm going to have x3 k minus 1. Okay. At this point, I'm finding x2. So I need to use the x3k minus 1 because I do not know x3k, right? I'll be able to find that using the third equation. Okay. And then I'll say this minus 3 x4 k minus 1 again, right? And then the last value is just 25. So I'll write it like that. I'll continue doing the same. So x3k, if I have x2 and x1, then I'll substitute those by these values that I've found in there. Okay. So this will just be equal to x3 will just be equal to 1 over 10. Then I'm going to have minus 2x1 k, because I've already found the x1 from the first equation. And then I'm going to have plus x2 k again. I can't use k minus 1 because I've already found the x2k, so I can substitute that value in there. And then I'm also going to find x4 there, it's positive, plus x4 k minus 1 now. Because I'm finding x3, so I can't use the xk here. I need to get the x4 k minus 1. So I'm getting this one from the initial approximation. And then minus 11 that I have at the far end. And then similarly, I'll be able to write the formula for x4k. So let me write it on top there. So let me do this. Let me change the color. And then write x4k here. So x4k, from there, I'm going to have 1 over 8. Then negative 3x2. Will it be k minus 1 or k? So in this case, it will just be k because I've already found small x2 k. Okay, and then the other one will be plus x3. This one will also be x3k because from the third equation, I will have found x3k. And then lastly, I have the constant, which is 15. So I'll be using these 4 equations to generate that sequence. And then I'll be able to find the approximation for each value of k. Can I move on to the next board?
Yes, sir.
Okay, good. So from here, I'll be able to find x11. It will have 1. So remember x11 will just have those zeros. So we are going to have 1 over 10 from this equation. Let me just get back to it again. Okay, so it will be x2 0 now, since I haven't found the value of x2 1. So I need to use x2 0. So this one will be similar to the one you found for the Jacobi's method. So it will be minus 2x3 0. Then plus 6. And you have x2 0. And in this case, again, we are using the initial approximation 0, 0, 0, 0 transpose. So you should keep that in mind. So it will just give us 0.6 because x2 0 and x3 0 is just equal to 0. So let me wrap this part. Good. And then I'll move on to x21. From the second formula, you'll be able to see that this will just be able to give you 1 over 11. Then I'll be able to use x1, then plus x3, 0, because I haven't found x3. So I'm going to have x3 0. Just a minute, ladies and gentlemen. Okay, x3 0 here, and then minus 3 x4 0. Okay, plus 25. I also have the constant 25. So I'm going to have 1 over 11 here. Then x1 will be 0.6. x3 0 is 0, then minus 3 0 plus 25. So you're going to substitute in there, and you should be able to simplify this and get x2 to be equal to 2.3273, right? Then to find x3 1, using that formula, I'll be able to get 1 over 10, then minus 2x1 1, and plus x2 1. I found x2, so I'll be able to substitute it in there, and then plus x4 0 minus 11. So let's substitute the values of x1, x2, and x4. So this will be minus 2, then x1 1, we have 0.6 here, right? Then plus x2 1, we just found that value. It's 2.3273. Then x4, we know that x4 0 is 0, then minus 11. So we should be able to simplify that, and it will give us negative 0.9873, right? And I know you can do the same to find small x4 1. So let me just demonstrate it to you on the next board. So x4 1, now it's going to have 1 over 8, then minus 3, x2 1. I'll use 1 because I've already found small x2 1, then plus x3 1, then plus the constant, which is 15. So we'll just substitute values of x2 and x3. So get negative 3. x2, we got 2.3273. Okay, then plus x3, we are just from calculating the value of x3. Actually, it's negative, so I'll change that to negative. Excuse me. Then we have 0.9873. Then plus the constant, which is 15. If we evaluate this, we'll be able to get 0.88789. Okay, so that capital X1 is now equal to what? X1 is the same 0.6000, comma, X1 now is, small x21 is now equal to 2.3273. And then small x31 is just negative 0.9873. And lastly, 0.8789. Okay, transpose. After doing this, you check the stopping criterion if it has been satisfied. So it would be capital X1 minus capital X 0, L infinite norm of this. So I know it's something that you can verify. And you see that this value will still be greater than 10 to the power negative 3. Okay, so you still need to do more iterations. Okay, so this is the Jacobi-Seidel method, and it is somehow similar to the Jacobi's method, only that we need to use the previous approximations to improve the new approximation that we are trying to get. Any questions on what we have considered, ladies and gentlemen? So in the notes, I've given you this as an exercise. You show that you need to go up to the 5th iteration in order for the stopping criterion to be achieved, or in order for this stopping criterion to be satisfied. Yeah. Any questions on what we have considered? Okay, no questions. Thank you so much, ladies and gentlemen. So we'll end here on linear systems of equations, so that on Friday we look at non-linear systems and look at other numerical methods that we'll be able to use to solve such systems. Okay. So somebody is asking me when I'll be able to post the videos. So I think I can do it right away. So let me just have a look at them and then I'll be able to post on Mood. Okay, thank you so much, ladies and gentlemen. We'll
Just
see
on a
you
lighter
on
note, sir.
Friday. Yes, sir.
Sorry, sir, on
We
a
need
lighter
that.
note.
We need
Yes.
that. Go ahead, please.
I just hope COVID will continue because I found this one to be a better method of teaching where me I'm understanding it far much better. I'm telling you, for me, actually, for me, I'm a 5th year student, and last year, although I was not writing the course, but I attended, and I never understood this topic. I had no clue. But this time I'm even able to teach others. Thank you so much. I think this is a better way to explain because you are patient and you are not skipping steps. Everything is very clear. Please let COVID continue so that we continue.
I'm happy to hear that, sir. But I want COVID to end.
Thank you so much.
Like you said, on a lighter note, we need to end with that. Thank you so much, sir. Let's end here. We'll meet on Friday.
Thank you. Okay.
Yeah, welcome.